Hi students, today we'll learn a brand new chapter, chapter 2, matrices. Yeah, so matrices are used in the field of mathematics to represent, and solve problems, especially in algebra, statistics, and geometry. And also in our daily life, in business, we will use matrices. We'll see in the next slide. So what we learn today, we are going to learn number 1. We learn how to represent information into matrices, and after that we'll determine the order of a matrix and also the elements in a matrix. And finally we will determine whether two matrices are equal or not. Okay. And then, before I proceed, do you notice that sometimes matrices it's used, but sometimes matrix. So are they the same term? Okay, I give you a clue. This one, matrix, and then here two matrices. Okay, what do you get here? Yeah, very simple. Actually, matrix, you say matrix if you have only one matrix, a matrix, a singular form. Yeah, and if more than one matrix, you say matrices. Yeah, this is the plural form. Yeah, same as what you learn in graph theory, network of graph theory. For a vertex, one vertex, and then if more than one, you say vertices. Okay, that is the new information for you lah. Yeah. Okay, next we'll see this matrices with how to represent. How to represent information in the form of matrices. So you have here this Kedai Electric Sinar Jaya records the sales of 3 types of fans. 3 types, stand fan, ceiling fan, and wall fan. And then it is shown that the sales is in store, and also online. So you have this information in March, April, May, and so on. So this is the information. How do you transfer into matrices? Okay, this information is in table form. So we want to transfer it into matrix, in a matrix form. So what you do, you just take the numbers. You take the numbers, you have 6 numbers here, you make one bracket, you write it back, 16, 18, 11, 5, 10, and 4, then you close the bracket. And the bracket, you can use the curved bracket or this one, but our textbook is using this one, this shape. So we use this one for our lesson. Okay, so in short, a matrix is a set of numbers arranged in rows, and columns, to form a rectangular or square array. Okay, so you must know what's the meaning of a row. So row, this is row. This is row. So this is row 1. This is row 2. So these matrices have 2 rows, right? And how many columns? Columns is the vertical arrangement, This one. This is column. This is column 1. This is column number 2. This is column number 3, or the third column. So you have 3 columns over here. Yeah. So remember, rows is horizontally and column is vertical. You don't mix it up. You will get confused later. Huh? So please, rows and columns you must be very good at. Okay, the rectangular and square array, that means this one, this type is rectangular. Yeah, rectangular matrix. So a square matrix, what is a square matrix? Square is when you have same row and same column. Let's say this one is 2, -3, 0, 4. Okay, do you see here? You have 1 row, 2 rows. Yeah, you have 2 rows here. And also here, what do you have? You have 1 column and 2 column. So you have 2 columns. So 2 rows and 2 columns is a square matrix. Okay, that is very easy. Okay, let's say example 1. Example 1, you have to represent the following information into matrices. Okay, for first question, it's already in a very arranged information already. So when you change into matrix, you just make the bracket and then you just write the numbers. Yeah, just write the numbers. So 1, I better use the white color. 1,700 and then 2,100, 2,000 and 1,800. Close. So you don't have to write. No need to put comma. No need to put comma. But this one should be written in a better way lah. This is too crowded. You put the bracket, and then 1,700, 2,100, 2,000 and 1,800. Close. Yeah, the bracket. And you can also write it this way. This is 1 row, right? This is a 1 row matrix. You can write also in 1 column. That means you start with 1,700 here, 2,100, 2,000 and then 1,800. Yeah, this is 1 column matrix. Yeah, 1 column. Okay, you can do like that. For B, B also quite simple. Yeah, you just write back everything here. Yeah, 13, 5, 1, 10, 2, 4, and then 8, 9. Yeah, no comma, no full stop, everything. You just write the numbers. And also you can change into you write the row become the column. Yeah, 13, 5, 1, 10, 2, 4 and 8, 9. Okay, the one also can. And for C, this one Samad scores 76, Okay, you can start with this, 76. And then for maths, it's 82. And then for history, it's 72. Okay, this is for Samad. For Hamid, okay, so your BM is here under 76. So BM is 80. Mathematics is 88. And then history is 70. Okay, you can write like that. Or you want to write like this, also can. 76 for BM, 82 for maths, and 72 for history. This is for Samad. And then for Hamid, 80 for BM, 80 for BM, and then 80, and then 88 for mathematics, 88, and 70 for history. Okay, you can write like that, either way. Okay, now we will determine the order of a matrix, and after that we will identify the elements in a matrix. Okay, the order of a matrix can be determined by counting the number of rows. This is very important, the number of rows first, followed by the number of columns in the matrix. So row first, then column. For example, okay, you have a matrix like this, You have a matrix like this. So what is the order? So first you calculate, you see how many rows. How many rows? 1, 2 rows. So you write 2. Okay. And then 2 rows, right? 2 rows. How many columns? How many columns? 1, 1, 2, 3. So you have 3 columns. You have 3 columns. So you say the order of the matrix is 2 by 3. 2 by 3. And most importantly, this is the row followed by the column. And if you write 3 by 2, it is wrong. It is wrong. And how do you read it? You just say 2 by 3. Not 2 times 3. This one, not that one. You say 2 by 3. Okay. And then every number, now we go to element. Element. Every number in the matrix is known as an element. So for example, if this is your matrix, you have how many elements? You have 6 elements. You have 6 elements. And then your number 4 here is the element at the second row. Second row. This is second. This is second row. This is second row. And third column, this is the third column for the matrix is number 4. And in a matrix, we use capital letter to denote a matrix. Let's say A equal this matrix. Yeah, this is the capital letter. And then the elements inside the matrix, we use a small letter. Yeah, we use small letter. But then, let's say here, A is this matrix. And then the element here, we use small letter. Yeah, if you use big letter here, A, the element will be in small letter. So let's say A. And then the next one also A. The next one also A. How do you differentiate? Yeah. To differentiate it, you just the location, yeah, the location. Let's say for this one, it is on the first row, yeah, row 1 and column 1. So your A will be A11. So this one is still the first column, but first row, but second column. For this A, this is the second row, but first column. So this is 2, 1. This one is second row, second column. Yeah. So if I say number 4 here, so the elements is A. Okay, check. It is first, second row, and 1, 2, 3, third column. So the elements is A23 is 4. Simple as that. You must remember the first one to write is row first. Then you can write the column. This is very important. Row first, then column. Row is the first one, then column second one. If you change it into column and row, this is already wrong. Yeah. Okay, now we'll see how to determine the order, yeah, the order and elements in a matrix. Okay, you are given 3 matrices, yeah, your P, Q, and R. So first we'll determine the order. Okay, for matrix P, let's see. For one row and one row by 1, 2, 3 columns. So 1 by 3. Yeah, 1 by 3. The order is 1 by 3. So for Q you have 1, 2 rows by 1 column. So 2 by 1. So for R you have how many rows? 1, 2, 3, 4. So you have 4 by, you have column 1, 2, 3, 4. So 4 by 4. Okay. So now we go to elements. Yeah, elements. So the first row and third column, P13. It's written as P13. So P13 is, we clear this one first. Okay, P13, yeah. That means the first row and the third column, it is 9. So the answer is 9. For Q21, that means the second the second row, okay, the second row and the first column, this one 5, this is 5, and then for R34, that means 1 2 3, the third column, and the fourth 1 2 3, fourth column. So this is it, 1. Okay, so no problem for you, easy, it's a piece of cake. Example 3. Given matrix D is this one. Determine the order. Okay, what's the order? Remember what? Remember RC, row to column. Yeah. So how many rows? 1 2 3. So the order for A, the order is 3 by how many columns? How many columns? 1 2. So 3 by 2. Okay, make it clearer. 3 by 2. Okay, done. For B, elements of D11, D11. So we erase this one. D11 will be first row, yeah, first row and first column. So D11 is -2, yeah. D21, that means second row, first column. This is 0. Yeah, D21 is, write it properly. D21 is 0. Okay, last one. D32. 3 is the third row, and the second column is number 9. So D32 is 9. Okay, very easy, a piece of cake. Okay, next is, now the final part is for today, how to determine whether two matrices are equal. So by logic, it will be equal if it has the same order and each corresponding element is equal. Meaning, if this one 1 2 3 4, so the equal matrix is 1 2 3 4 lah. Elements, all elements corresponding element is equal, then it is the same order. This is 2 by 2, this is 2 by 2 also, and all elements are in corresponding order. Yeah, 3 is here, 4 is here. Okay, so let's see. Okay, let's see example 4, how we determine whether the following pairs of matrices is equal or not. So, and we have to give the reason. Okay, let's see matrix A and matrix B. Is it equal? Yes, it's equal. Why? What's the reason? Okay, because it's equal because both matrices have the same order and each corresponding element is equal. Okay, so B is done. A is done. So for B, what do you think? Is it the same? Oh, of course not, because it is not the same order, and the corresponding elements also not equal, right? See, C is not the same as D, matrix C not the same as matrix D, because both matrices do not have the same order. The order of C is 1 by 2, while this one is 2 by 1. Okay, for C, what about this one? These two. Yeah, the order is the same, but the corresponding elements is not equal, huh? So corresponding elements are different. Okay, for D, this one order 3 by 2. This one order also 3 by 2. Okay, and the elements 0.5 and 1/2 is the same, right? Only this one is in decimal form, this one is in fraction form. Okay, 2, -2 is -2, corresponding element is the same, -1, -1, and 12, 6. Okay, 0.8 and 4/5 is the same, yeah? 4/5 is actually 0.8 also. So D, yes, G is equal to H. Matrix G is equal to H because both matrices have the same order and each corresponding element is equal. Okay. Okay, next example 5. Okay, given matrix P, this one, and matrix Q, this one, determine the values of X, Y, and Z if P equal to Q. Okay, P equal to Q. That means if P equal to Q, that means each element in P must be equal. The corresponding element X must be equal to 5. X must be equal to 5. So you have answered what is your X. Okay, 7 must be equal to Y. Y plus 1. So your Y is actually 7 minus 1, 6. Y is actually 6. And lastly, this one, 5 minus 3Z equal 2Z. Yeah. So 5 equal, this one you bring here, you'll have 5Z. So Z is 1. So you got it? Okay, so very easy. Matrix is one of the easiest topic also, in Form 5, Maths kssm. Okay, I think that's it for introduction to matrices. So I hope you got all the 3 learning standards just now. And if you have any questions, you can always ask me. And the most important thing is you do your exercises, because maths needs your hard work. You have to do a lot of practices. Okay, keep on loving maths and keep on learning maths. Okay, thank you.